Hello everyone, welcome back to my channel. Today we are continue with the chapter applications of the derivatives. In this video we will start with some more questions of the exercise 7e. In the previous videos I will discuss about the questions of this exercise which is related to the application of the maxima and minima. Now let us start with the next some questions which are most important for the examination point of view. Now let us start. Question is, show that height of the cylinder which is open at the top of the given surface area and greatest volume which is equals to the radius of its base. That means we show that height will be equals to the radius of its base. Let this be the cylinder having the height H, and this cylinder is open at the top. That means this area is open and this is the closed area, and this is the radius of the cylinder R. Radius is R. In this, firstly we will let R be the radius of base of the circular cylinder and H be its height and V be the volume and S be the total surface area. Then we have to find its volume which is greatest. So for this, firstly we will write the formula for the surface area of this cylinder which is open from the top and closed from the bottom. If this is closed surface, that means this is the circle having the area pi r square. So surface area will be equals to pi r square plus surface area of cylinder will be equals to 2 pi r H. So total surface area will become pi r square plus 2 pi r H. So from this, H will be equals to S minus of pi r square upon 2 pi r. This is the value of H. And the volume of the cylinder will be equals to pi r square H. That means it will become, by putting the value of H here, we get volume will be equals to pi r square into S minus of pi r square upon 2 pi r. So this will be equals to the volume of the cylinder. From this we get pi r square S upon 2 pi r minus of pi square r raised to the power 4 upon 2 pi r. Now we have solved this. Pi will be cancelled out and r will also cancel out. Then we get pi 1 by 2 take common and we get 1 by 2 into s r minus of pi r cube, which will be equals to the volume V. Now we have to find dV by dr, that means derivative of V with respect to r. Then here we get 1 by 2 into S minus of 3 pi r square. Now if we will take dV upon dr will be equals to 0, then it gives 1 by 2 into S minus of 3 pi r square will be equals to 0. That means from this r will become equals to root of S upon 3 pi. This will become the radius. Now if we have to find d square V by dr square, then we get 1 by 2 into 0 minus of 6 pi r. That means we get minus of 3 pi r which will be equals to d square v by dr square. Now for r will be equals to root of s upon 3 pi, d square v upon dr square will become minus of 3 pi into root of s upon 3 pi. That means here we get the term minus of root pi 3 pi s, which is less than 0 because it is in negative. So therefore the volume is greatest at r will be equals to root s upon 3 pi. Volume is greatest at r will be equals to this. Now from first equation, that means we have find h will be equals to, in the first equation we will find h will be equals to s minus of pi r square upon 2 pi rh. That means here we will put the value of r. So we get h will be equals to s minus of pi into s upon 3 pi divided by 2 pi up into root of s upon 3 pi. Then from this h will become equals to 2s upon 3 divided by 2 root of pi s upon 3. That means h will become equals to 2s upon 3 into root 3 upon 2 root pi s. Then we get it will be equals to root of s upon 3 pi. So the height will become, and radius will also become equals to root s upon 3 pi, which is proved above. So therefore height will be equals to radius of its base. So hence proved. Now next question is show that the height of right circular cylinder of the maximum volume that can be inscribed in a given right circular cone of the height h, which will be 1 by 3 h. That means firstly we will take a cone like this. In this cone, the cylinder inscribed in this cone, that means the cylinder is here. This is the cylinder. And cone having the height 1 by 3 h. We will let this be equals to y, and this is the radius of the cylinder. This is the point A, B, and this is the point R, which making an angle alpha here, and this point is small a, and Q will be there. Now let us start. Firstly we will let this be the point P. Firstly we will let PR will be equals to h, be the height of cone, and PQ will be equals to y, which is the height of cylinder. Then in right angled triangle RQB, like this, RQB, which will become RQ upon BQB, which will be equals to the cot alpha, which will be equals to the base upon perpendicular. That means base is RQ and perpendicular is QB. So from this now we will put the value of QB, which will be equals to, this is the x. That means here we get RQ upon X will be equals to the cot alpha, that where QB will be equals to X. So RQ will be equals to X cot alpha, and Y will become equals to PR minus of QR. That means from total we will minus this term, then we get from the distance PQ, that means Y. That will become H minus of X cot alpha. Now we let V be the volume of right circular cylinder, which will be equals to pi r square H. That means here it will become V will be equals to pi r, that means radius of a cylinder will be equals to X square, and H will become H minus of X cot alpha. So this is the volume. Now we derivative this term, that means dV upon dr, then dx, then we get pi into X square derivative of H minus of X cot alpha plus H minus X cot alpha derivative of X square. That means here we get the term pi into X square minus of cot alpha plus H minus of X cot alpha into 2x. That means dV upon dx will be equals to pi x into 2h minus of 3x cot alpha. Now we have to take dV upon dx will be equals to 0, then it gives pi x into 2h minus of 3x cot alpha will be equals to 0. That means 2h minus of 3x cot alpha will be equals to 0, as x is not equals to 0. So from this term x will become equals to 2h upon 3 cot of alpha. That means 2h upon 3 into tan alpha, because 1 upon cot alpha will be equals to tan alpha. Now we have to find d square v by dx square, then we get pi into x minus of 3 cot alpha plus 2h minus of 3 x cot alpha. Then here we get the value pi into minus of 3x cot alpha plus 2h minus of 3x cot alpha. That means it will become pi into 2h minus of 6x cot alpha. And when x will be equals to 2h upon 3 tan alpha, then d square v upon dx square will become pi into 2h minus of 6 into 2h upon 3 tan alpha into cot alpha. That means it will become pi into 2h minus of 4h. That means minus of 2 pi h, which is always less than 0 because it is in negative. So therefore v is maximum when x will be equals to 2h upon 3 tan alpha. So therefore y will be equals to h minus of 2h upon 3 tan alpha into cot alpha. Put the value of x in the y. That means in this equation y will be equals to h minus of x cot alpha. Here we will put the value of x, then we get this term, which will become equals to h minus of 2h upon 3, that means h upon 3. So this is the result. Now in the next video we will start with this with the topic approximation of this chapter. If you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.